Alright, hello and welcome back everyone to our third lesson in indices. This one is where we start looking and getting into what we call our index laws. There are 4 index laws in total that we're going to be covering. And sometimes when people think of the word law and they think of mathematics, they think it's going to be the worst thing in existence. But what I want you to do is keep in your mind that these index laws are nothing more than a shortcut. They're actually going to make the questions that we do quicker and easier. It allows us to essentially just cut out the working out, really. So I think you will, if you're a person that hates having lots of lines of working out and things like that, you may actually end up learning to love the index laws. So with that being said, let's just get straight into it. So for our lesson today, here we go. We're going to cover multiplying, and we're also going to cover the index law number 1. And the reason we're only covering index law number 1 is because this is the one that we can use to shortcut the multiplying questions. Okay, so you'll definitely need equipment. You're going to need, you will need book, you'll need pen. And this one here, if you're really bad at times tables, you might want to have a calculator with you. With that being said, there's only a couple times you need to use times tables, and they're not particularly too hard. So a lot of you can probably get by without a calculator. Definitely have book and pen. So if you don't have them, pause the video right now, go get your equipment, come back, and we'll continue with our lesson. Alright, so first thing I'm going to need you guys to do is get in our notes for today. Like I'm saying, I'm trying to keep the notes as short as possible. You know, just like me with mathematics, often writing down and reading out notes doesn't particularly help. Often it doesn't really make a whole lot of sense until you actually see the question and see the thing happening. But with that being said, there is a place for it, and hopefully the correct place is right now. So the heading for today's lesson is Index Law 1. Copy that in, and this is our 1 sentence for notes. Once that's in, you can obviously unpause the video and we'll continue. All right, so what I'm going to get you to, or I should say, what does it say? Hey, when multiplying algebraic terms with indices, we can use Index Law 1 as a shortcut to getting the simplified answer. So that's all it really does. And to illustrate this point, I want you to consider this. Yes, I'm going to get you to copy this into your book as well. I might get you to wait until after we've done it though. So maybe just really watch and focus on what I'm about to do. At the end, I'll get you to pause it and you can copy in what we've done. All right, so we have x cubed times x squared. Now, a lot of the times, and what we're going to be doing is simplifying it, right? What is this thing going to be equal to? Right, lots of people would probably guess, that, hey, it's maybe going to be x to the 6 or something because we're multiplying. Well, since you don't know index law number 1 yet, let's just work this out the way that we've learnt, right? What have we learnt so far in this topic? Well, we've learnt what a base and index is, so that's kind of cool. But as far as actual skills, we've learnt how to write in expanded notation and we've learnt how to write in index notation. So let's do that. Let's look at this. X cubed, right? What actually is x cubed? Well, x cubed means x times x times x, right? That was legitimately what x cubed is. And you can see that it's been timesed by x squared. What is x squared? X squared is, of course, x times x. So I've written them out in expanded notation, right? X times x times x, and that's been multiplied by x squared, which is x times x. So I've used expanded notation to get this, and now I'm going to use index notation. So if you have x times x times x times x times x, right? There's 5 of them in total. How would we write this in index notation? So hopefully you haven't skipped lessons and you have covered the second lesson. Index notation, this would just be x to the power of 5. And this actually is our answer. So if we go back up to the original question, x cubed times x squared, it wasn't x to the power of 6. This ended up becoming x to the power of 5. How did we get it? Well, really simple. We wrote it out in expanded notation. And then once we did that, we were able to simplify it and write it in index notation. So you can certainly see why our last lesson, that's why we covered those 2 skills, right? Because that is certainly the way that you answer these questions. Now, I said to you that, and as you can see from this method, it works, and it actually wasn't that bad. You can see, though, how it could get quite annoying. Like, we had a 3 and a 2 as our indices. What happened if it was a 7 and a 10, or a 15 and a 20? This line of working out, right? This line here was our working out. And you can see how irritating that would get if we had large indices. Well, the good news for us is we have this thing called the index laws, and they are going to allow us to completely cut out this working out line. So we're going to redo this question using an index law. In this case, because we're multiplying, we're going to be using index law number 1. And all the index law number 1 says is, hey, notice how we had x cubed, so there was 3 x's, and over here we had x squared, there was 2 of them. Well, index law says forget all that working out, forget expanded and index notations. If you're multiplying, all you have to do is keep the base the same and add the 2 indices. That's it. So when you're multiplying, right, and the bases are the same already, just keep the base the same, you just add the indices together, and you have your answer. How quick and easy is that? So this page is looking a little messy here, but I'll get rid of the stuff that we don't need, just so you know exactly what to get copied into your book. So I actually will get you to get this copied into your books. And I'll just put over here, this is using the index law. We just add the powers. Or I could have, as you know, just as easily have said, add the indices. I was meant to say powers. All right, so pause the video. If you haven't already copied this in, pause the video now, get this copied in, and once done, we'll continue on with our lesson. All right, so now that we've sort of seen one example of how we would solve these sorts of questions using expanded and then index notation, and then we've seen how by using index law number 1, you can actually shortcut and cut out that working out step. Here is officially index law number 1. Here you've got a to the x times a to the y. When multiplying them, notice you still are left with the a there, right? The a hasn't changed, and all you're doing is just adding the 2 indices together. So that is officially index law number 1, and it's nothing new. All it is just a shortcut that we can use when multiplying. I've got 6 examples here. Don't stress. I'm actually going to be going through these ones for you. All I want you to do at this point is just watch. Oh, by the way, make sure you've got that index law number 1 copied into your books. Pause the video if you need to. All right, so on to these, our 6 examples, right? So these will cover from the simplest up to sort of the hardest that you're going to need to deal with as far as index law number 1 goes. All right, so for the first one, you got n to the power of 10 times n squared. Both the bases are the same, right? It's both n. Notice we don't change it. It doesn't become like a 2n or anything crazy like that. The base stays the same. All you need to do is then just add the powers. All right, so forget writing n times n times n. I'm writing out n to the power of 10, by the way. Right, you can see how toxic and wasteful to your life this would be. You know, I don't even think I've done enough yet. And then you'd be multiplying it by n squared, where you'd have another 2. Right, instead of all that working out, we can just use the index law, which says, hey, you're multiplying, that's fine. All you need to do is just add the 2 powers together to get your answer. This next one, a to the 7 times a squared. Again, notice the bases are the same. Keep the base the same. It's an a. Add the powers, and you have a to the power of 9. The next one, you know, like, what would you put here, right? If we were in the classroom, I would actually ask, you know, what are you guys thinking? And there's only 2 possible answers I'm going to get given. Some people would say a to the 7. Some people would say a to the 8. So, you know, decide maybe which one you would be. But certainly, if you have been following along all the lessons in the correct order, you would know that this a at the back, this second one right here, does actually have an indice, and it's a 1. So certainly, if you were an a to the 8 kind of a student, you'd be right on this one. All right, on to example 4. Here we have, see this 3 here and see this 2? That's just a normal 3, and that's just a normal 2. There's no, you know, indices above it or anything like that. They're just normal 3 and a normal 2. And notice how we're timesing. So we already know how to do the 3 and the 2. That's not new for us. You know, you learnt how to do that right at the start of primary school. Our first part of this question is we have an ordinary 3 times an ordinary 2. You're going to get an ordinary 6. So we've got the 6 out the front. When we look at the p's, right, these p's, there are bases with the powers. This is the thing that we're going to use our index law for to shortcut. So, right, so when multiplying terms that have these powers, that's when we use our index laws. The base stays the same. We've got a p, and we add the powers together. 5 plus 2 would give you 7. On to the next one. Here we have an ordinary minus 5 times an ordinary 3. Minus 5 times 3, right? 5 3s are 15. There's one negative, stick it out the front. You got negative 15 out the front. Just a normal negative 15, just like you've seen in all your other previous years of study. When we move on and work out what we're doing with the ends, notice the ends have indices above them. So this is where we need to use the index law, right? Index law for when there's indices sort of makes sense, right? Keep the base the same and you add the powers. So 11 plus 4 gives you 15 there as your power. And final one, here we have like the x's and the y's both have indices above them. So we're going to need to use the index law twice, once for the x's, once for the y's. In this case, x times x squared. That's going to become an x to the cubed. And here we have a y cubed times y squared, right? Keep the base the same, add the powers, you get y to the power of 5. That's it for our examples, right? Taking us from the easiest up to the hardest. That last couple minutes as we went through these examples is the most crucial part of this lesson. If you're still feeling a little bit dodgy with it, you know, feel free to just pause, rewind the video back a little bit and just rewatch this part again if you need to. Once you're feeling okay with it, continue on. I've got some questions for you guys to do to finish off our lesson. You know, the sort of normal deal. Oh, and by the way, if you haven't yet, you know, you need to get these examples copied into your books, right? When you're looking back and you're studying, you're prepping for your exam, having the examples right there with solutions is crucial. Okay, this is it for our lesson. There are 6 questions for you guys to do yourselves. So pause the video, copy these questions into your book, and have a go at answering them. Once you've answered, you know, the best you can, and you know, once you're happy with the answers you've got, unpause the video and I'll put the solutions in, and you can see, you know, how much you actually understand of index law number 1. Alright, so hopefully you've had a chance to actually go ahead and do these questions yourself. You haven't got lazy and just sort of played on and, you know, just wait for me to do it for you. You know, genuinely try it. If you get stuck on the last couple, that's understandable. You know, they're a little bit tricky there, to be honest. But hopefully everyone was able to do the first couple themselves. And so the first one, you should have had a p to the 10. The second, you should have had an x to the 4. The third one, you should have ended up with a times a. You should have had an a squared and a b to the 3, right? This next one here, you had normal 7 times a normal 3. Hopefully you had just a normal 21 out the front and a p to the 22 at the end. All right, on to the last two. Minus 2 times minus 4. You know, you could type in your calculator if you wanted, but realistically, it's not that bad. 2 times 4 is 8, and the 2 negatives make a positive. So I'm just going to keep it as a positive 8. And then use our index laws for the next parts. Here you got 15 plus 10. That's going to be a 25 right there. All right, and on to our final question. So in this case, you should have had hopefully an a to the 4, a b to the 5, and a c to the power of 2. Alright, if you know what to do, if you've got any questions or any concerns, of course, feel free to let me know either through YouTube or back on Canvas. Let me know and I'll help you the best I can. Hopefully everything's going good, right? This lesson was your first index law. You can probably guess what the next lesson's going to be. There's 4 index laws in total. We've just done number 1, which was the multiplying index law. All right, best of luck with everything, and I'll see you guys in lesson number 4.